My name is Isaac, and today I will present the paper Qualifying Software Engineers Undergraduates in DevOps, Challenges of Introducing Technical and Non-Technical Concepts in a Project-Oriented Course. I'm the author of this research with my supervisor, Dr. Rocha. So, teaching DevOps is exceptionally challenging due to the novelty of the team and the complexities of concepts, ranging from a set of agile practices to automation that allow the continuous delivery and continuous deployment. The present study investigates and presents the lesson learned of a course designed to teach DevOps concepts through the development of capstone open source projects. Our paper wants to answer the following research question. Can a project-oriented course help to teach both technical and non-technical DevOps concepts to undergraduates? Suppose the undergraduates are presented only from a theoretical point of view. Understanding how continuous delivery is impacted by both pipeline automation and culture of collaboration is challenging. For example, the culture of centralizing information influenced by the practice of maintaining communication on issues and pull requests, which are non-technical concepts, directly impact the continuous and reliable release process, which are technical concepts. Therefore, presenting these concepts in practice enrich the theoretical discussion with real problems faced in the project's day-to-day development. And this research question guides us to plan, execute, and evaluate this course focused on DevOps. Science's first offering in 2016, more than 240 students enrolled in this course, creating a community around it. The collaboration culture developed goes beyond this course. We employ open source standards that involve students in their first contact with a project-oriented course, team management, and the guidance of mentors. And the most important, this community must be a safe environment for the students to learn and fail, ensuring open collaboration and open communication. We used the DevOps conceptual map from our previous paper, a survey of DevOps concepts and challenges, to design this course. This work divided DevOps concepts into four categories: people, process, delivery, and runtime. People and process category covered non-technical concepts of DevOps, such as culture of collaboration, breaking down silos, and short feedback cycle, such as delivery and runtime covered technical concepts necessary to enable continuous deployment and monitoring. Among these categories, runtime was the least covered in the course, due to the course time and the technical complexities of these concepts. We employ the basic concepts of runtime categories such as infrastructure as a code, virtualization, containerization, and cloud services. Staying out of this scope, concepts such as runtime experiment, A/B testing, and log management. The concepts related to people, process, and delivery, such as a culture of collaboration, short feedback cycle, agile, lean, and continuous delivery and deployment, were strongly applied and presented to students. Presenting these concepts and the encouragement to apply them in projects seeking new technologies and new knowledge. The course and culture were being built and improved each of her using the feedbacks and metrics collected from the repositories. To evaluate the course syllabus and the relevancy of these practices, we extracted data from 148 repositories corresponding to 72 projects at the course organization on GitHub. The goal is to understand how the students employ DevOps concepts in their projects. We also designed an online questionnaire to collect feedback from students about methodology and DevOps. The goals of this questionnaire is to verify if the students could perceive the complexities and correlate technical with non-technical DevOps aspects. We received 86 valid responses, and we analyzed these using descriptive statistics and open coding of textual responses. When we correctly apply the concepts of DevOps, an increase in team productivity is expected. Therefore, the objective is to assess whether students are applying the concepts present in the project's development and the impact on productivity. As presented in this figure, we analyze commits per project from 2014 to 2019. We can note the line representing the commits over time, highlighting the periods in which the course was focused on Agile and DevOps. The increasing of quantities of commits represent an improvement of productivity perceived overall in the course, reflecting the adoption of concepts and practices from delivery and runtime category. The restrictions, which are more detailed on paper, help maintain similar architecture and complexities between the projects. We also collect and present information about the impact of culture of collaboration, the technologies used, and the average of students' perceptions of knowledge before and after this course. This information is still more detailed on paper. The course has a culture of feedback and continuous improvement that enable to collect informations and insights looking at the data, the teachers' insights, and feedback from students and partners who have gone through the course. During these years, 9 lessons learned were raised. First of all, culture is a key factor. DevOps culture is fundamental to make continuous delivery and deployment effectively. And as already present, culture was created around this course to ensure open and transparent communication to help share knowledge. With the commitment to keep technical communication centralized on issues, the team are organizing themselves to maintain this culture using bots on communication channels and other tools to maintain the communication centralized. The second is encourage the use of different technologies. Students are encouraged to choose the technology and framework that best meet their project needs and are recommended to select emerging technologies. In this process, teachers emphasize that concepts are more important than tools, and each technical choice should be attached to a DevOps practice. This freedom enables innovation and keep the course up to date with the current practices and tools used by the DevOps community. The course doesn't provide a plan for the software development, as in a real project, making the team exercise their management and decision-making skills. Several students reported that not having a plan to be followed caused insecurity when making decisions. However, they understand the importance of decision making and how this impacts on delivery. DevOps tools are changing rapidly, and most of them are open source. The use of these tools impact directly the project development. And in order to keep discussion, concepts, and tools up to date, it's important that project-oriented courses employ the current standards of open source community and DevOps. As common in a project-oriented course, a student's portfolio in collaboration with the local software industry help with the gap between academy and industry. We have tested several mentoring formats, and we understand that it has an impact and make a difference in education. Still, it is necessary to experiment and adapt to the specific context, as it doesn't have a solution. All the models tested has a positive and a negative aspect. Team versatility is important because DevOps requires a versatile and skilled team. Therefore, the professor should encourage the students to assume responsibilities and tasks that correspond to their interest. Each student assumes at least one role throughout the project, like tech leader, developer, architect, and operator. It means that at the end of this course, students will develop distinct abilities and technical competencies. It's important to have students focus on making decisions, taking quality, performance, risk analysis, and making appropriate choices when necessary. It is essential that professors do not focus only on projects or product metrics. The team engagement, management maturity, the innovation, team communication effectiveness need to be considered in grading and assessing students. And to finish, it's beneficial to involve external evaluators and give feedback from the team, based on industry and academy perspective. They also have different experience and may bring new questions and suggestions to the course. To finish, I would like to emphasize that learning DevOps from experience is more important and beneficial than a purely theoretical approach, because it's evidence how technical and non-technical DevOps concepts are connected, and how they impact on the final delivery. Well, to conclude in this presentation, I would like to invite you to explore and contribute to our community at this link or scan this QR code. Thanks for the opportunity e obrigado pela atenção.
So we are live. Welcome to the Q&A session for this paper. I have with me here Carla and Izake, who are available to answer your questions. So if you have any questions, please use the chat window to post them, and we will go from there. Or comments. We'll wait for a few seconds, see whether anything's happening.
Okay, thank you. Everybody who show up.
Yeah, sometimes this happens and everybody's like busy typing something and then they all come at the same moment. But I can start in the meantime because I have one question. So the topic that you're trying to teach, DevOps, is very difficult topic because it defies definition and then it doesn't have a formal definition. It's basically, in a way, kind of a bag of lots of different concepts that includes all the modern technologies, all the modern software practices. It's kind of a soup of buzzwords. So that presents a lot of challenge because it's an important practice, it's an important concept. We want the students to be familiar with it. But when you try to teach and then you start with, I don't know, a concept map of 100 nodes consisting of these latest technologies and buzzwords, and then you say, do you understand what it is about? They don't say, yep, I got it. So how do you start?
Exactly, that's a challenge. And a previous work that the research that we did was exactly like a survey on the concepts of DevOps, trying to have like a definition and what these concepts are, because some people say the culture, so some people say it's technical. And then our previous work was like a survey to map the DevOps concepts and challenge. So we use like non-technical like concepts like agile and processes, and at the same time there is the buzzwords about technology and automation and pipeline and continuous deployment and infrastructure as a like this all these concepts you have to share with students of undergraduates. So the challenge is how you can connect these concepts, like how communication will affect your pipeline, how is the interface between the operations and development, how the development can have a common vocabulary with operations team and uh, bridge this gap of communication and guarantee the continuous deployment. So it's really challenging. And this experience, this class, we teach for over 5 years. We have different professors, different setups, and we gather this lesson learned. And we believe that we already have a framework that we apply to different contests over the last years.
So we have a question and a comment from Tim along the lines that I have just mentioned. So Tim is saying DevOps is probably one of the concepts that is challenging, that is changing fastest due to rapid technology evolution, and includes some very complex issues like orchestration. It is also, I think, one of those topics like project management that is best to learn either on the job or at least after students have had work experience. So any thoughts about that? Learning DevOps during your studies or on the job or after you've had some practical work experience?
Yes, thank you, Timothy, for your comments and your question. And I think it's really pertinent. Yes, it's different where what you teach in a school, in a university, with it's really control the risk and everything, and what they learn on the job. But the challenge is to teach the concepts that they know the vocabulary that for instance project management, what are the struggles a project management face when dealing with DevOps. So when it comes to the jobs, he won't have like a mature experience, but he'll know the vocabulary and he knows a little bit of how project management affects the deployment or the continuous delivery.
Do you have, like, I don't know, when you're teaching students, do you have one or two slides that just defines the scope of DevOps?
We use from our survey. So it's a culture of collaboration between development and operation teams that wants to enable continuous delivery in a software
Okay.
context.
All right. Okay. So yeah, I think they need something like that, at least to frame it. And then you can talk about which concepts, additional concepts, are actually connected to that scope. But sometimes I see it being taught as just a loosely connected ensemble of
Yeah.
different technologies and different practices. And in that case, students get confused because they don't understand what the relationships are.
Yes, and you don't understand the complexity, actually. For example, like Timothy said, orchestration. But what is the impact of orchestration to the deployment, and how the communications over the features on the pipeline is impacted over this kind of decisions? Is like on the keynote speaker previous, like Professor David, he said the architecture is not only a set of teaching, is not only a set of decision about technical skills. You have to have like these conversations with different stakeholders, and to teach this complexity in a classroom is the main challenge that we want to try to solve through a project-oriented and with a lot of lesson learned that you can see in our paper.
Right. Is there anything that you have not mentioned in your 10-minute video because it was short, but you want to emphasize now to the audience?
I guess something that we've been learning is like collaboration outside the university is a key factor from what we're doing, like to keep up the industry very close to academy and keep it fresh, the concepts, the technology, and the culture of the development. I think it's something that we're learning.
How do you do that? Within the context of projects led by industry, or do you have, like, I don't know, guest lecturers who come and talk to the students about these different DevOps concepts?
We do a little bit of everything. Like we have mentorship from people from the academy or from the industry. You have like stakeholders that they propose a problem that we solve in the development of the project. You have like keynote speakers that come to talk about their problems in the industry that it's related to the course. So it's kind of a little bit of everything. They come to the final evaluation to give the feedback from their perspective. So we have like this many interventions from the industry that fine-tune the course, I guess.
And including open source community too.
Sorry, Isaac, could you repeat that?
And including open source community too.
I see. All right. Okay. Well, thank you very much. If you have any last words, go ahead. Otherwise, thank you for your paper and for answering the questions. We have another minute and 22 seconds before the discussion room is open, and I invite you to go there when this session is over. But otherwise, maybe let's give it up for Carla and Isake for answering the questions. Virtual applause.
Thank you very much for your time. I hope you have time to read our paper and contribute, because everything we do, it's open source, so everything's available. Unfortunately, in Portuguese, but
okay, that's good to know. Well, there's always Google Translate, you know.
Yeah, awesome.
Fortunately. Thank you very much. I hope you enjoy the rest of the conference.
Thank you.
Thank you for the opportunity.
And thank you, the audience, for attending the Q&A session. In about 20 seconds, we'll be moved to the discussion room. So let's just wait for that.
All right.
I guess this is the worst part about this virtual environment, and that there are these awkward, silent periods that you don't know what to do about.
But it happened face to face as well, so it's okay.